Yes, we are ready for a flight. Please make sure your seat is in the full upright position. All right. If you've ever flown, you probably heard that. Maybe not. All right. What's a geometric sequence? So we dealt with an arithmetic sequence. Now we need to deal with a geometric sequence. What is this? Successive terms. Successive terms. That means one right after the other. Differ by a, and then we're going to finish in green. Successive terms differ by a, and here's the key, constant multiplier. By a constant multiplier. A geometric sequence. All right, so don't write this, just by way of review. Remember, when we did an arithmetic sequence, don't need to write this. It would look something like this, right? 7, 11. The next one would be 15. The next one would be 19. And that's an infinite arithmetic sequence, right? Goes on forever. And there was a common difference. And the gap was 4, and the gap was 4, and the gap was 4. It's common. That difference is the same all the way throughout. Okay, so that's an arithmetic sequence. What about a geometric sequence? Again, don't write this yet. I'll give you an example for your notes in a minute and stuff like that. But if I had 4 and then 8 and then 16 and then 32 and then 64 ... This is a geometric sequence. And what we want to, on this one, look at is, what's the constant multiplier? In other words, what would you multiply 4 by to get to 8? 2, right? So this is a times 2. What happens when you do 8 times 2? And what happens when you do 16 times 2? And 32 times 2? And 64 times 2? And you'd be able to get the next number continually on. Because in a geometric sequence, you have a constant multiplier. So it's different. Now, it's kind of neat, and there's all kinds of patterns in these things, and those of you that are really into patterns and stuff, you can play around with it. You know, if you look at the gap here, this is a 4 gap. Again, don't need to put this in your notes. And here now, what do we have? A 12 gap. And then we have, what, a 16 gap. And then we're up to a 32 gap. And you can play around with the gaps and try to figure all that stuff out. This is an 8 gap. So a 4 gap, then an 8 gap, then a 16 gap, then a 32 gap. So what's happening to the gap? The gap is also doubling. All right. So the gap between is doubling as the numbers double. And there's all kinds, again, as I said, there's all kinds of patterns you can look at with sequences. So geometric sequence, what you got to do is keep straight is the fact that with geometric sequences, you don't have a common difference, you have a constant multiplier. So let's do an example, and we'll put that sequence up here. 4, 8, 16, 32, 64, and ... will make it an infinite sequence. 4, 8, 16, 32, 64. And in this one, that implies the constant multiplier. You know what? Instead of saying all that, let's just do an arrow from it, right? The constant, the constant multiplier in this case is 2, right? So again, we'll just come back here so you understand, and we'll just do a times 2 on each of these to help you remember when you look back at it how it's all working, right? And that's not a 0.2, that's supposed to be like a raised dot. Times 2, times 2, times 2, times 2. Okay, so for an arithmetic sequence, how do we designate the common difference? What did we use to represent the common difference, Nick? I'm looking for a symbol. Kirsten? we used the lowercase d, right? Represented our common difference, and that's pretty easy. We also need a symbol for the constant multiplier. So the constant multiplier I'm going to say this, back to blue, is also called and I'll finish in green, common ratio. Also called the common ratio. And a common ratio, we would then use the lowercase letter, what would you guess? R. 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 It's R. Missed your chance. There it was. For you to be a pirate, but I guess you're just not into it. So you missed your opportunity. So the constant multiplier is R, which is also the common ratio. So with arithmetic sequences, you have a common difference. The gap is always the same. For a geometric, the multiplier is the same, but notice the gap goes up and multiplies each time as well. How could you find R? How could you find R? Let's do the sequence. Let's go 3, comma 9, comma 27, comma 81, dot, dot, dot. Question, Raquel? You know it already. Awesome. And sometimes it's very, very obvious. The common ratio is 3. If you ever have a situation where it's tricky, because you know what? The common ratio could be like 3/2. It could be. Common ratio could be 1/5. Could be negative 2/7. It could be. It could be. Because there's all kinds of common ratios. So the way you would figure it out mathematically, this one was easy. We could do it in our heads. But the way you do it mathematically is you would take a term. You don't want to take the first. You take the second. You could take the third. You could take the fourth. Whatever term you want, if you'll take it and divide it by the previous term. Right? N minus 1 means the term before, right? Don't let that scare you. It's just a way of saying a general statement. All this means is take a term and then the previous one. Divide it by the previous one. So, for example, we could take the 9 and divide it by the 3, right? And didn't that give us the 3 common ratio? Right, I took the second and divided it by the first. Or how about if we take the fourth? We'd have to divide the fourth by the third, right? And again, it doesn't matter. No matter what successive terms you do, if you do a term divided by its previous term, right? And that's the key. This is the previous term. Divide any term by the previous term, and you'll get R. 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 Number 2. Somebody want to say hi to Mom? He didn't wave, though. Didn't wave. You got to look over there, not over at me. All right, there you go. Okay. All right, pirates. No mutinies, otherwise it'll be trouble. Okay, so when we did arithmetic sequences, we had a recursive formula and we had an explicit formula. So for geometric sequences, we're going to have a recursive formula and we're going to have a explicit formula. What was the limitations of the recursive formula? Anybody remember? And again, I know all this is new, so you have to be careful here. You have to review this stuff because it's all brand new to you. But there was a limitation to the recursive formula. It was only valuable if you knew something. Kirsten, the previous term. The recursive formula is great, but it only helps you if you know the term before. And that is the exact same case with the geometric sequence. So the recursive formula, and I'm just going to go FORM for short. And again, we're going to put in parentheses, must know previous term. Must know previous term. It's only valuable when you know the previous term. So it's a sub n, something general for everything. There's the a sub n minus 1, right, the previous term. And it's pretty easy. It's times r. R. Right, which is the common ratio. R. All right. Man the cannons. All right. So that's the recursive formula. Again, there's value if you know a previous term. There's not a whole lot of value if you don't know the previous term. It's just the way it is. So let's do one example. We'll get on to the more valuable one, and that's the explicit formula. So example. Let's suppose we had the very boring sequence of 1, 5, say it. Got it already? 9? No, we're geometric. 1, 5, 25, 125. We better go ... huh? But it would be 625 next. Okay, let's go ahead and just list out R. So R is going to equal what? Say it if you know it. 5. And again, if you didn't know it by intuition, then you could always take a term and divide it by its previous term. 5 divided by 1 is 5. 25 divided by 5 is 5. 125 divided by 25 is 5. Pretty easy one. We can figure out the term. If they asked you for the 5th term, right, because we listed term number 1, 2, 3, and 4, you would simply take the 125, right, the n minus 1, and multiply it times the r, the 5, and you'd get 625, and you'd go on. If I asked you for the 37th term, you'd say, oh man, I'm going to be multiplying all night, because now you got to do 5 times the 5th, and then 5 times the 6th, and then 5 times the 7th, 5 times the 8th, and on and on, and on and on, and on and on, and on and on, and on and on it goes. And too many ons. Let's make that A. Let's do B. I want to do one more thing. Write the specific recursive formula. If, write the specific recursive formula. If, here's our sequence. Are you ready? 4, don't say anything now on this one, comma, -8, comma, 16, comma, -32, ... So that's a 4, comma, -8, comma, 16, comma, -32. Now, hold on. Let's set this up right. Let's write the general formula. A sub n equals a sub n minus 1 times r. And really, all you can do is put in the r. That's all you can do. Once you do that, you've got the specific formula. So on 3, tell me what you think the value of r is. Here we go. 1, 2, 3. Good. It would have been a lot better if Kyle would have yielded to the stop sign a whole lot better. Look, this isn't free-for-all, folks. This is Learn Math. Learn Math learns real well when I want you to answer something, but when you want to carry on and be a fool, then we have problems. So I heard a lot of, I heard -4s and -2s, and obviously it's a -2, right? Take a negative 16, a negative 32 divided by 16, that's a negative 2. Take a 16 divided by a negative 8, that's a negative 2. Take a negative 8 divided by 4, that's a negative 2. And the value of r is a negative 2. Now, when a number is multiplied times a variable, and a sub n minus 1 is a variable, do we put the variable in front or the number in front? What goes in front? The number, the coefficient goes in front. So that negative 2 should end up in front of the a sub n minus 1. And that's the answer to the question. But again, the limitation is you can only find a term if you know the previous term. Other than that, it won't help you. You can only find a term when you know the previous term. All right, let's get on to the more valuable formula. And 3, that's the in red explicit formula. The explicit formula. Starts off same way, a sub n. All right, if you remember the explicit formula for an arithmetic sequence, what came next? Anybody remember? Raise your hand and tell me. What's next? Alexandra? Very good. It was a sub 1, and it's a sub 1 again. Because we're doing the explicit formula. Now, for the arithmetic, we had to go plus parentheses n minus 1 times d. We still have an n minus 1. We don't have a d, though. We have an r. So this is times r. And believe it or not, the n minus 1 is an exponent. This is an exponent. So very, very similar. We start off with the a sub 1. Common difference is add, so we added n minus 1 times d. But geometric is constant multiplier, so we multiply times the r. The difference is the exponent is the n minus 1. Okay, so let's see how this works. Let's see how this works. Let's do an example here. That should be blue. Come on, blue. So for example, let's suppose we had the sequence 3, comma 12, comma 48, dot, dot, dot. 3, comma 12, comma 48. Let's find a sub 10. Let's find a sub 10. Okay, so when you go to write your explicit formula, a sub n, and look, write them. I always want you to write them because I want you to remember them. When you write it, you say to yourself, I need to know 2 things. I need to know a sub 1. Do we know a sub 1? What is it? Say it if you know it. 3, because we know it's the first term. Okay. Now, it doesn't tell us r, but we can find r, right? And so on 3, tell me the value of r. 1, 2, 3. Good. So 12 minus 3 is 4. So r is 4. Okay. So now we know that r is 4. We know that a sub 1 is 3. And we're ready now to use the formula. What does it want? It wants a sub 10, right? What is a sub 1? It's a 3. What is r? It's a 4. And the exponent is going to be 10 minus 1. It's a big number. And we like these a whole lot better when we use a calculator on them. So let me just show you the next step. Whoa. Love that pen. So, still got it. A sub 10 equals 3 times 4 to the 9th power. It's a big number. I'm going to use my calculator. What's the order of operations? Somebody say it out loud for me. What do you do first? So I better do that. I better do the 4 to the 9th power first, shouldn't I? Because that's the order of operations. So here's what that number is. So a sub 10 equals 3 times, oh my soul, 1, 2, 3, 1, 2, 3, 116,652,904. And then we got to multiply times 3. I put it higher for you. Again, with the calculator, it's no problem. Doing it longhand would be a big pain. So, man, that looks funny. Let me check one more time. Yeah, that's what it is. So I end up at a sub 10 equals 349,958,000. Whoa, I'm off. Oh well, blah blah blah. I'm off a power here. 3, 3, 3. This is 3,499,587,119. Just the 10th term. Oh my soul. Is that even possible? It's possible. You're multiplying everyone by 4. I guess. I don't like that answer. That's weird. All right, I'll check and look at that. Make sure that that's right when we come back on Monday. All right, this is, and you'll breathe a sigh of relief. The only thing I want you to stop, don't pack up. I got to talk to you. Here's what I want you to bring out of this lesson. I want you to know that a geometric sequence has a constant multiplier, and we call that constant multiplier R. That's all we're going to worry about with geometric sequences. Not giving you homework over it. That's all we're, because I don't want you to get them confused with the arithmetic ones. And I'm afraid that'll happen. The rest we'll build on later in our math career. Tonight's homework. You need to watch the video on lesson 4.7. And that's base 10 and other bases. Very important lesson. Very cool lesson. Oh, I gotta get you guys sheets.